Okay, first thing we're going to investigate is the rules of ratio. Can you add things? What things can you add? What things can you multiply? The multiplication rule you should already be familiar with just from our simplifying exercise yesterday. Multiplying and dividing are effectively the same thing. You just turn multiplying by 2 into a divide by 2, into a divide by a half. They are linked. So with the rules of ratio, the key thing to remember is that we need to keep things in proportion. And that means that compared to either the total or to each other, there is the same multiplier to go from one value to another. So if I give you a ratio of 4 to 5, the way to multiply to go between these two numbers, or the total, the proportion of the first part is 4/9. The second part is 5/9. Now, anything we do must simplify down to this proportion. That is the simplified version. So let's try adding 2 to both sides. If I add 2 to both sides, what happens? Well, I get 6 to 7. The total is 13. So the fractions I get are going to be 6/13 and 7/13. Are these in the same proportion as 4/9 and 5/9? Well, no, you can't easily convert them. There's a difference here of 1, there's a difference here of 1. So adding a number doesn't work. You can't just add a number onto a ratio and make it work. Let's try a different one. Let's try multiplying. Let's try multiplying by 3. So 4 times 3 is 12. 5 times 3 is 15. The total is 27. Mr. Boothwood's extension, when you're talking about proportions which are parts, not scales, as in maps. So we've got 12 over 27 and 15 over 27. I look at the two fractions, both of those will divide by 3. So this is going to be 4/9. It's simplified to one of my fractions. This one, both the numbers divide by 3. Strange, it's the same number both sides. And that simplifies down to 5/9. So this multiplying by 3 rule is perfectly valid. It keeps the parts in proportion to each other, the same proportions. I've got 4/9 and 5/9, 4/9, 5/9. So this is perfectly valid, multiplying by a number. There's one more weird one. These two are in proportion. As long as they have common proportions, all those proportions are the same, we can do something a little bit weird. What I can do is I can add the two ratios that are in proportion. They're describing the same amount. So 4 and 12 is 16. 5 and 15 is 20. Total is 36. Let's check the fraction. 16 over 36 and 20 over 36. What numbers go into both of them? Well, I know both of these will divide by 4, so let's divide it by 4. And that gives me 4, and 4 times 9 is 36. Look at these two, both of these numbers will divide by 4. Strange, same number again. And that gives me 5. And 4 into 36/9. So this adding of two ratios, if they are in proportion, works. Okay, so you can either multiply a ratio by a number right through, and that will work. Or if you've got two ratios that are in the same proportion, you can add the number parts together and it will keep the ratios in proportion. That's the basic rules. So with a ratio, what we can do is if I've got two numbers, what I can do is I can multiply them by some number k. That is the same ratio. And if I add two ratios that are in proportion, so if I add kn plus n, oh, actually let's do a different one, and say, and I'm told another one that's in proportion, a to b. So n and m, both of these are in proportion. Now what I can do is I can do n plus a and m plus b. If they are in proportion, they must be in proportion. If they're not in proportion, n, m, and p, q. If I try adding these together, it won't give me a proportion. So these are two different ones. So we can multiply a ratio to give us a new ratio, and we can add two ratios that are in proportion. It's important they're in proportion. So I'm going to do an example for a concrete mix. We'll start off with everything being measured in the same unit. So we'll only look at the dry parts of concrete. And the concrete mix that's deemed to be quite strong is a ratio called 1, 2, 3. So, and the parts are cement, sand, that's fine, very fine stone all rounded up, and gravel, which is small chips of stone. That makes a good mix. There is a separate part which is to do with water, but these are by weight. These units are weight. Okay. So we're going to solve some problems with them. First of all, if I have 50 kilograms of cement, I want to know how much sand and gravel do I need to make the total. Well, Mr. Boothwaite's extension starts off with 1 to 2 to 3, and the total weight is 6. So this is my total on the end. This is why I'm not talking about the water component at the moment. We know cement, sand, gravel, so I'll think about that. Cement, sand, and gravel. And we've been told we have 50 kilograms of cement. Just like I've said with all the other stuff, a lot of maths is about being able to make sure you know which bits belong together. Well, the 50 kilograms belongs with cement. So how did I change from cement into the kilograms? I multiplied by 50 kilograms. So the sand, 100 kilograms. Gravel, 150 kilograms. I can either add these together or do the same thing for the total. Because we're not losing this in any way, at the end of this we're going to wind up with 300 kilograms. This works because these are the same units and nothing's going to be changed in the way. So what if I have a new question with, let's go for 75 kilograms of gravel. What's the final mix going to be? Same idea. Start with my 1, 2, 3, and what's the total? So what I do is I put in the number where I know it. So I put the first number, I knew it was there. This time I know the 75 kilograms is gravel. Gravel is under the 3, so 75 It's down there. How did I change 3 into 75? If you never know how this change happens, remember to go from one line to another when you don't know everything, you're going to multiply. So to find out what you multiply by, you can always do what is 75 divided by 3. 75 divided by 3, and that tells you what your multiplier was between the two lines. Divided by 3, and that gives me 25. So I'm going to multiply by 25. End, start, and that gives me multiplied by 25. Go through the other parts, do the same thing. So 2 times 25 is 50 kilograms of sand, and 2 times 1, 25 kilograms of cement. Overall, total 6 times 5 is 150 kilograms. Or if you're not sure, add the parts together. 25 plus 50 plus 75, 150 kilograms. Last one, I want 720 kilograms. So if we want 720 kilograms of concrete. The first thing to think is when they talk about concrete, that's the total. So I'll set up my ratio, 1 to 2 to 3, with a total of 6, and the 720 belongs with the 6. How do I change 6 into 120? Grab my calculator, ending at 720 divided by the start of 6 gives me a multiplying factor of 120 kilograms. So that means I need concrete 120 kilograms, 240 kilograms of sand, and 360 kilograms of gravel. Okay, so this actually now gives us the ratios that go on. This bar thing on the right also has an alternative use. It's what it makes, it's not necessarily always the total. It effectively makes another part. So let's do a pancake mix. Okay, so this is another use of ratio in recipe type things. This actually is a pancake mix, and it makes 8 servings, and this is how I'm going to show you another way to use this bar notation to say what it makes, what the total is. So the parts are flour, and that is now in 1 1/2, 1.5 cups. We've got 3.5 teaspoons of baking powder. So that's 3.5 teaspoons. We need 1 teaspoon of salt. Need 1 tablespoon of sugar. So there's a lot of sugar in this. One and a half cups of milk. I'm just trying to move my sugar. 1.5 quarter cups of milk. 1 egg. And this tablespoon of butter melted, There's some form of oil. I'm not going to put it in here, but what is important is what this actually makes. What it actually makes is a total of 8 servings. So the total is makes. So none of these actually have the same units. So this is not just add these numbers together. Hope that doesn't just work out if you did. So if we wanted to scale this now to say, I want to make 4 pancakes, I only want a small make. Let's go the other way. Say I've got 3 cups of flour. It's all I've got, but I want to use all of it up to try and make my recipe. So what I can do is, how do I change 1.5 cups into 3 cups? End divide by start. Our multiplier is times 2. So we've got 7 teaspoons. Times 2, we need 2 teaspoons. Double the sugar, 2 tablespoons. Milk, double that, is going to be 2.5 cups. And we now need 2 eggs. And the question is, what does this make in total? Multiply the line, and that gives me 16 pancakes. Now, one of the little finesses I showed you earlier with using these is, say I was trying to make 24. I want 24 pancakes. Well, you could do this line. How do I multiply? And that gives me 8 times 3 gives me 24. But if you think of this as being 1 portion and 2 portions, this is 3 portions. So I can add 1 portion to 2 portions to make 3 portions. And I can do the same with all the other quantities. So I actually can go through, and if I want to go from 8 to 24, what I can do is do 8 plus 16 equals 24. Because these are in proportion, I just add all the other numbers as I go through. So I need 1 and 2, 3 eggs. I need 3, and that's 2 quarters, 3 quarters. So 3 and 3/4 cups. I've got 1 and 2, I need 3 tablespoons. I need 3 teaspoons of salt. And I need 3.5 and 7, I need 10.5 teaspoons of baking powder. And I need 4.5 cups of flour. So all the techniques you can use are, I can multiply a whole line to give me a new line, and then I can add them. Now we've done lots of things, these sorts of things in the past, to do with fractions, percentages, doing those box trails. This is the same thing, it's now just laid out in lines. And what's handy with these is you can do this in a spreadsheet without too much problem. So that's using the ratios. Okay, so this exercise 10C, go and play about with it. There's a load of word questions. I would expect in about half an hour to probably be able to do 10 to 12 of those questions. Exercise 10C. And please mark your work.